All right, let's talk Pythagorean triples. So these are right triangles that are good to memorize, because if you see these numbers and multiples of these numbers, you'll be able to figure out the missing side length, no problem. So if I see a 3 and a 4 as the legs of my right triangle and I'm trying to find the hypotenuse is always going to be 5. This is a 3, 4, 5 triangle. And just to prove it to you, right, if we use Pythagorean theorem, so 3 squared plus 4 squared is equal to what? Well, 3 squared is 9, plus 4 squared is 16, so that's going to be equal to 25. So remember, if we call the hypotenuse C, right, we start with a squared plus b squared equals c squared. So that means c squared is equal to 25, so the square root of both sides. Do that, and you'll get c is equal to 5. So again, just proving that 3, 4, 5 triangles are a thing. And multiples of 3, 4, 5 triangles, the same logic and the same rule applies. So for example, I had 6 down here and then 8 over here. Well, I just multiplied this 3 by 2, and then that 4 also by 2. So I'm going to do the same thing over here for the hypotenuse. So I got 5 as the hypotenuse in the last triangle, so this one's going to be 10. So multiples of these Pythagorean triples also apply to the same rule. So if you wanted maybe like, if this was 25 and then this was 20, right? It looks like we're multiplying the original 3, 4, 5, all the side lengths by 5. So that means this one down here is going to be 15. All right, so now I'm going to give you 3 more Pythagorean triples that you might run into. The next most common one is going to be 5, 12, 13. And again, just apply Pythagorean theorem to these numbers and you'll see that it works out. So you got 5, 12, 13, right triangle. We've also got 8, 15, 17. So the classic 8, 15, 17, right triangle. And the last one is going to be a 7, 24, 25 triangle. So if, again, you plug in these numbers to the Pythagorean theorem, Pythagorean formula, whatever you want to call it, you will get both sides of the equal sign equal to each other, and proving that these triangles are Pythagorean triples. So they're good to memorize, so you don't have to use the formula.